Alright guys, we're continuing section 10.4 today. I know that there was no new vocabulary, no new theorems, just some more practice to make sure we're good. And this first one, notice they give us one angle measure that's outside of the circle and one angle measure that's inside of the circle. So we could really write a couple of equations if we're given enough stuff about angles inside of the circle or angles outside of the circle. So let's start with the inside of the circle. We know that this angle is 120 degrees and we have its vertical angle over here, which would also be 120 degrees. And because we know we have some linear pairs, we know that each of these angles would be 60. Now, when I'm talking about an angle that's inside of the circle, that measure should be 1/2 of the sum of its arc and its vertical angle's arc. So we could talk about x, but we really are also, we're going to need this arc over here. So I'm going to go ahead and just refer to that arc for right now as y. I know we don't need to find it, but I need it to be able to write an equation. So I could say that that 60 degrees was equal to half of, and because we're talking about an angle inside the circle, it's half of the sum of its arc and its vertical angle's arc. And it doesn't matter which order you put those, I'm just going to say x plus y. That 60 should be half of the sum of its arc and its vertical angle's arc. Now, I really have another equation because I have a couple unknowns now with this angle that's outside of the circle. The angle that's outside of the circle, that 15 degrees, should be half of, now because we're talking again about two different arcs that I don't know, I know I need that larger arc minus the smaller arc. So 1/2 of, because it's outside of the circle, their difference of x minus y. Well, notice that here I've got a system of equations. I'm going to need to solve the system of equations. And if you either distribute that 1/2 throughout there, or really if you multiplied the whole equation by 2 to clear that fraction, either way, you could use some elimination pretty easily. I'm going to go ahead and I'm going to multiply everything in the whole equation by 2. That's using that multiplication property of equality. That's going to make this top equation a 120 is equal to, the 2's are going to cancel, so just our x plus y. And for the second equation, if I multiply this whole equation by 2 to clear that fraction, that's going to make this a 30 is equal to an x minus y. Well, now it's set up for elimination. If I add those two equations together, I already have opposite y values. Alright, so our y's cancel, and as I add these two equations together, we should end up with a 150 is equal to a 2x. So then when I divide both sides by 2, we're going to find that x is equal to 75. Now on this problem, all we had to do is find the possible value of x, so x has to be 75. And that's talking about the degrees of that arc CB. Alright, for the next one, they ask us to find the possible values of x. And I just want you guys to take a look at this one, because notice that they give you two arcs, which we've got an angle inside of the circle, so we're thinking the 1/2 of the sum of the measure of its arc and its vertical angle's arc. But notice that the arcs that we're given are not of this angle measure or its vertical angle. So what we really need are these two angle measures right here. To find that, what we need to do is we need to think about these two are a linear pair. So if this is 12x, this measure right here should be 180 minus 12x. And you could think about them either way. So we know that that angle measure, that 180 minus 12x, should be half of, and again we know we're doing a sum because we've got an angle that's inside of the circle. So 1/2 of the sum of its arc and its vertical angle's arc. So the 3x plus 8 plus the 7x plus 12. So 1/2 of that sum, which when we go ahead and combine some like terms, we're going to say 180 minus 12x is equal to half of, and our 3x plus 7 would give us a 10x, and our 8 and our 12 would be a 20. Now, here's one where I might just distribute that 1/2 because they're both even values. So we have 180 minus 12x is equal to our 5x plus 10. And as we solve this equation, we could go ahead and add 12x to both sides. And we know, and we could also subtract our 10. So we'd end up with our 170 is equal to a 17x, and when you divide by that 17, x is 10. All they asked for again was the values of x, so there we go. X has to be 10. We could have substituted that in to find any of the arcs, to find any of these angle measures, but all they'd asked us for was x. All right, on this next problem, notice here I've got a point that's on the circle. But again, they're giving me the angle that's outside of here, and I want the angle that's represented by that tangent and that secant line. So we know that together these two make 180 degrees. So if I take 180 minus the 160 minus 9x, so minus that whole quantity, this is really saying I'm going to take 180 minus 160, but when I'm subtracting a negative 9x, that would be plus 9x. So altogether, that's really just 20 plus 9x. Now, once you have this angle measure, we can go ahead and write our equation. We know that this angle is going to be half of the measure of its intercepted arc. So that 20 plus 9x should equal half of that arc, that 2x squared plus 80. And when we go ahead and distribute the half here, since they're both just even numbers, we are going to have our 20 plus 9x is equal to an x squared plus 40. Notice that we've got a quadratic equation. So to solve a quadratic equation, we want to set it equal to 0 first. So let's go ahead and move everything over to the same side. So minus our 20 and minus 9x. And I'm going to write it in standard form as well. So we've got 0 is equal to our x squared, then we want to put our x's, so minus our 9x, and then our constants, plus 20. So here we've got a quadratic equation. You could solve this by factoring, you could solve this by completing the square, you could solve this by using quadratic formula. I'll say that the easiest method to use, when possible, would be to solve by factoring. So to determine if this is factorable, I'm finding factors of 20 that would add to give me my negative 9. Well, 4 and 5 are factors of 20 that if they were both negative, they add to give me my negative 9, and they do multiply to give me my positive 20. And you can go ahead and kind of use our little shortcut you probably learned in algebra to say x minus 4 and our x minus 5. Just when the leading coefficient is 1, you can go ahead and put those two factors into you can put the factors of 20 into the two factors of that quadratic equation. And when you're setting them each equal to 0, x minus 4 equals 0, or x minus 5 equals 0, you'd end up with two solutions. Here, if I add 4 to both sides, x could be 4. And over here, if I add 5 to both sides, x could be 5. So we have two possible solutions for this one, two possible values of x. And you could go ahead and substitute these into our two scenarios, into our 2 points, and they both actually will end up working as well. So x could be 4 or 5. All right, now for this next one, we're supposed to find the measure of this angle out here, which this angle should be 1/2 of the difference between that larger arc and the smaller arc. But notice that we don't really have either one here. But they do give us another angle measure, and this is an angle that's on the circle. So that angle, because it's on the circle, it's just half of that intercepted arc. So if 64 is half of this arc measure, then we know that that arc measure would have to be double that, which would be 128. Now, if you look at these two arcs together, this 128 as well as that larger arc that you see out here, notice because these are both tangents, those two arcs together form the whole 360-degree circle. So if you take your 360 minus the 128, that's where you could find the measure of arc ADB, which would be 232. Now, once I know that this is a 232-degree arc and this is a 128-degree arc, now I can find the measure of angle 1. So the measure of angle 1 is going to be half, and because it's outside the circle, half of the difference of our 232 minus the 128. And if you go ahead and combine those like terms, you're going to say the measure of angle 1 is equal to half of 104, and half of 104 for the measure of angle 1 should be 52. So the measure of angle 1 should be 52 degrees. All right, for this last one, notice what they've given you. We're trying to find this measure of this angle, which I would need the larger arc minus the smaller arc, the difference of those two, half of the difference of those two. But I don't have that measure yet, but I do have all of the other arc measures within that circle. If you do 360 minus the 175 minus the 85 minus the 95, you'd find that this is just a 5-degree arc right here. So the measure of angle 1 in this problem should be half of the difference between the 85 and the 5. So the measure of angle 1 would be half of 80. So the measure of angle 1 is 40 degrees.